So try data structure. It is used to insert and search any word or number. So mostly in a try data structure, right? It mostly a single node consists of a character, and that character can be anything, right? So this try data structure, it is used to insert and search and perform an operation on the top of it. So the try data structure, the word try comes from the word retrieval. So if you will see, right? Can you see this? So this try word comes from the word retrieval. So you need to understand two things, that there are two important functions which takes place in the try data structure. One is the insert and the another is search. So if you guys are able to understand the trick of insert as well as search, you guys can solve any questions related to the try data structure. Let me give you an example. Let's say you have a word called Kohli and all the letters are small letters. So initially what happens is you are going to start with the root node. And in this case, since it is consisting of only small letters, right? So each node is going to have 26 edges, correct? So let's say this edge corresponds to K. Are you getting my point? So you are coming to this node. Now after that you are coming to O. Then you are coming to this node. Then after that you are getting H. You are coming to this node. Then after that you are getting L. You are coming to this node. And then after that you are getting I. You are coming to this node. And this node is the leaf node. Why? Because after this you don't have any other thing, right? And there is one important concept of leaf node. When we are going to define the structure, right, we are going to mark that specific node as leaf node so that you guys will be able to understand that, okay, this is the leaf node and this is the end of this specific word on which you are inserting, that you are inserting into the try. So that is why leaf node plays a very important role. Are you guys able to follow this till this point? Let's say, so this is the first word which you have inserted. Now let's say the second word which you are trying to insert is Koram, or let's say core, as simple as that. So what will happen? You will start from the root node, correct? So you will check that, okay, this edge already exists. As a result of which you don't have to create a new edge, right? Because it already exists, you can take this part. Now you can take this more path O. Now you will see that, okay, R edge doesn't exist. Then what you will do, you will add one extra R over here, and now you will add this. So now basically what it is going to store, if you will concat, basically add each and every, append each and every character which is there into this edge, right? Ultimately, this will signify KOR. Then this is one word. You can mark again this node as leaf node. And via this leaf node, you are going to identify that this node is marking as this node is a specific word which is present into your input. Otherwise, you won't be able to figure it out that whether this word is present in my input or not. So this is the significance of marking leaf node. Are you guys able to understand? Anyone having any doubt or concern?
Ranjan, what about like if we have word like KOHR?
Yes. If you have word like QHR, so now what will happen? You will come till this point, QH, correct?
Right.
Now you will see, does R exist over here? No, right? So what you will do, you will add one more edge over here with R, and then now this is going to signify KOHR.
Okay. It will
Does
not.
this make sense?
Yeah.
So basically what you are going to do is, you are going to start from the root node, right? You will check that, okay, if that edge exists or not. If that edge exists, good enough, go take that route. If that edge does not exist, basically you need to create one edge. So in simple terms, basically you can consider this edge as a road. So let's say you are this is your source and this is your destination, right? You will check that, okay, does road exist? You will say that yes, exist. Simply take that road. If the road does not exist, then you will have to build a new road, and then you are going to add that specific node via that road. Is it clear to you now? In the simple layman terms.
Yep.
So this is all about insert.
Duplicate. It can have duplicate node, leaf node.
Sorry.
It can have duplicate leaf node, right?
How it is going to have duplicate leaf node? The thing is that let's say you are having Kohli, right? Again, if you're trying to insert Kohli, what will happen? It will say K-O-H-L-I. So you will not get an opportunity to insert it, right? Because it's already exists. So it will avoid that duplicacy. Did you get my point?
Yeah, but on other label, like we can have the similar node which is already there in other label.
I didn't get your point.
I'm saying like we can have leaf node as duplicate, like which can available at different label. Like as I ask you a question about this KOHR, then R is already at our label, and we are adding there another leaf node as R. And in that case, like both the node are duplicate at different label, right?
Yes, exactly. So it's not like the last level is going to be the leaf node. If that is marking the end of the word, right? Obviously, that is going to be the leaf node, right? Leaf node is just to signify that this word has ended, and this is how it is just to signify that, okay, this is one of the word which was provided to you in the form of input. That's it. Are you getting my point?
Yes.
Let me explain with the help of one more example. Let's say your input is India, or let's keep it as all the letter is going to be small. India. This is the first word which you need to insert, and the second word is Indian. So what you are going to do, you are going to start with the root node, right? And then since I does not exist, you are going to build an edge over here. Now you are going to add one more node. Then after that, you are going to add one more node called N, because N does not exist. Then after that, you are going to add one more node called D, then because D does not exist, right? After that, you are going to add one more node I, because it does not exist. After that, you are going to add one more node called A, correct? Because it does not exist. So this basically adds your leaf node. So this is how you are going to insert India over here, correct? And then after that, since you are inserting the another word called Indian, you will add one more N, and this adds the another leaf node. This is how two words are getting inserted. Make sense? Is it clear?
Yes.
How the insert works? Now similarly, let's say when you want to search, you will say that, okay, I exist or not. Then move to the next character in the input. You will move to N. You will say that yes, N exists. Then you will come to D. Then you will come to I. Then you will come to A. And then once it is there, that specific word is there, just make sure that that is leaf node or not. If that is leaf node, so your input is basically present into your trie. So this is how the insert as well as the search operation works. And whenever you're typing anything in the Google, right? So you see that on the basis of the prefix, Google gives you some suggestion. So it is on the basis of this TRIE data structure only that they extrapolate. Are you getting my point? So in questions related to the prefix, whenever you get the feeling that, okay, it is like oriented towards the prefix kind of a question, right? And it is related with the string. Most of the times be assured that, okay, this is going to get solved with the help of a TRIE data structure. We are going to see few problems which can string related problem which can get solved with the help of TRIE data structure. And yeah, you guys will be able to figure it out that, okay, how you guys can solve questions on the TRIE data structure. Again, the concept is pretty simple. You guys need to understand only two things: insert as well as search. Once you are able to figure it out, insert as well as search, right? The rest of the problems which can be solved with the help of a TRIE data structure using those two tricks only, you guys can solve any questions on the TRIE data structure. No worries. But the only two operations which you need to understand pretty nicely is insert as well as search. Does this thing make sense to all of you?
Mention this this node can store the space characters also.
Sorry.
this can store the space characters also, like in
No. It is, see, the thing is that during the interview, the interviewer will say you, okay, the letters are going to be small letters or letters are going to be capital letters. In most of the cases, it is going to be small letters only, because it cannot show space characters, because how will you figure it out whether this is a space or not? So just assume, for the interview point of view, they are definitely going to say that, okay, it only contains, the string contains a small letter, because
Okay.
each and every node can have 26 edges, right? And if, let's say, the interviewer states it can have, let's say, a capital letter as well, then each node can contain at max 52 edges. Are you getting my point? So basically, if, let's say, you are having only 6 nodes, so it will be in total 6 to the power 52 in the worst case, the space complexity. Are you getting my point? Let's say if you're
Okay.
having only 6 nodes, so obviously each node can have, let's say this is the first node. How many level it can have? 26. Now let's say you are coming to this node, right? It can have 26 branches. Similarly, even the second node can have 26. Third node can have 26. Are you getting my point?
Yes.
So that is why most of the, it will be small letter only. Don't worry about that spaces, because you have to deal with the word that is given to you.
Okay.
Simply insert that word into your try and simply search that word. And mostly the operations will be related with prefix calculation, something like that. So the only two things which you need to figure it out is how you, the code which will help you in figuring it out, that okay, how the words are getting inserted and how the words can get searched. If these two operations are clear to you guys can solve any questions related to try. No issues on that part. So does this thing make sense to each and every one of you?
Yes, Ranjan.
Anyone having any doubt or concern?
Just a small query. So
Yeah.
you said like every node has one character, right? Like, or it can have up to 26 character, right?
Yep.
Like from A to Z. Can it hold the, any string at each node?
See, it cannot. This age is basically denoting a character. Are you getting my point?
Mm-hmm.
At the same time, it cannot hold any string. So each age is responsible for holding a single character. That's it. You can assume that, okay, when you're reaching this point, what is your string getting appended? I. At this point, it is IN. At this point, it is IND. Are you getting my point? At this point, it is INDI. At this point, it is INDIA. So this is how you can assume that it is getting appended, but normally one age is responsible for a single character to take you from the one node to the another node.
Okay.